Hello everybody, today we'll be doing smallest range. You are given an integer array nums and an integer k for index I, where I is between 0 and length nums. We're going to change nums I to be either I plus k or minus k, and the score of nums is the difference between the maximum and minimum element in nums. Return the minimum score of nums after changing the values at each index. So let's take a look at a couple of these examples. In the first example, we see that there's no change and it's 0. The second example, we notice that we're going to increase the 0 and decrease the max number so that we can get a smaller range. Lastly, in this last problem here, we see that there's a 1, 3, and 6. We're going to increase the 1, increase the 3, and decrease the 6 to get a maximum number of 6 minus 3. So the 6 is going to be here, and the 3 is going to be there. So we get the minimum difference between these numbers. And you're asking, probably this is very confusing, and how do we do this? So at this point, yeah, you're right, and there is we have to make more observations about how this is going to happen. But the time complexity is that we're thinking of at this point is O of n, and space is O of 1. That's the time and space complexity that we're thinking about. However, immediately you would notice that we are looking at the maximum and minimum numbers, so we do need to sort this array. So immediately, because the minimum number has to be increased and the maximum number have to decrease, so we're looking at n log n immediately. And of course, space-wise, that's fine because, well, we're just sorting. So anyways, so first, that's the first thing. Next thing is that here are the edge cases. The edge case is that these are all the cases that are possible already, because we have one item, that is the minimum, and everything after 3 is basically the same, and we have 2 items. So with the 2 items, we notice that we have to increase the minimum number and decrease the maximum number. So that's going to be our start. How we're going to do this actually is that, as you can see here, the difference between this number and the next number is the closest between each number, and 3 and 6 and so on and so forth. That's where they can become closest. And so we will need to increase the left side. So we'll increase the left side and decrease the right side to get the maximum. Of course, we do have to handle the edge of the array. So this is going to be our max number or min number here on this left side, and our max number on the right side that we need to handle, because this might spill over our min and max number, as we can see here in this example. As you can see, this is currently our, if we have this as our max number, and we subtract k, right? And we have, this is a spillover, because this min number plus k now is greater than our max number minus k. So this is going to be selected rather than this item, and our min number is going to be, of course, this number here, this number here, subtract the 3, and our min right, our right number minus k, and between, of course, this number here plus k, our min plus k number. This is left plus k when we're looking at this item here. The difference between these two, as you can see, this here at the max here between is going to be 6, because the left plus k is going to be 6 or 3, right? And so we're going to select 6. And here, the minimum number is going to be, let's say, a 1 plus k, which is 4, or it's going to be right minus k, which is going to be 3. And so we're taking the minimum of these two, the smallest of the two, and the bigger of this number, 6, and 6 minus 3 is equal to 3. Output is 3. So that's how it's going to work. The matching is a linear search, because the reason for this, why we chose to do this, is because the closest numbers between the range between the left number and the right number is going to be the smallest range possible. The only edge cases here, again, are the edge where we need to handle that, because those are where the minimum number and the maximum number can be. Because the left I and I plus 1 is closest range. And also we need to handle the edge of array. And so the plan is going to be pretty simple. Linear search the array and keep min and max number in bound. Or, yeah. So here's the plan. Let's implement it. So here's the bounds that we're looking at. So min number and max number is going to be nums 0 and nums at -1. Then what we're going to do is that the result is going to be the max number minus the min number, and we can get started with that. So so for I in range, length nums -1, we're going to set left and right, like num left and num right is equal to, so this nums at I and nums I plus 1. Then what we're going to do is the new max num is going to be the max of the max number minus k, or we're going to add, so this one, left num left plus k, and new min number is equal to the min of the min number plus k, or num r minus k. So with that, we can set our result to be equals to the minimum of the result of the new max number minus the new min number. Let's run over the code once afterwards to make sure that we understand it, because this is quite confusing. So let's run the code. Let's run the test cases, see if we got it. Okay, everything looks good, and let's submit. Oh, look, we have one incorrect answer here. We have a 277. That's because we did not sort. So we do need to sort for this to work. So let's submit one more time, or let's just throw that into our test cases to make sure that we can handle that case properly with the sort. And we did. And with that, we have solved the problem. I think the problem was that we forgot the sorting here, sort and linear search. We probably should add that sort in here, because that's why we forgot as we kept on moving down our list of code. With that, we have solved the problem, but let's check out how this works one more time and in our review. So because this is not easy. So what we set as our min num is going to be 1, and our max num is going to be 6, right? So the max difference at this point is going to be 5 because, well, we can just increase both sides by 3, and that's our max. That's our max difference at this point, or minimum difference at this point. Okay, so with that, let's move on to our first nums L and nums R. So nums L and nums R is going to be equal to 1 and 3. And we're going to select the new max number, which is going to be 6 minus k. So new max num is equal to going to be 6 minus 3. Or it's going to be nums L plus 3. So it's just 1 plus 3, which is going to be 4. And the new min number is going to be nums 1 plus k, which is 3, or we're going to take nums R, the 3, minus 3, which is 0. So we have a 0. So our max difference here between the two is going to be 4 minus 0. So our results is now going to show 4. So one question I would have right here is that why didn't we select 1 plus 3 to be 4 minus 4? Why can't we do that instead, right? Why didn't we do that? Well, we're looking for the minimum number between the two and the maximum number. Remember, we're looking at this item and see how far it can reach, and this number where how far it can reach to 0. And we're looking at the difference between the two because that's the maximum number difference. And we're also handling, what we're going to handle is the minimum number from this side and the maximum number from this side, which is the edge of our array, remember? So we want to make sure that we have the edge in mind, that can be our minimum number. However, there can be cases where this becomes greater and lesser. This becomes lesser, so the middle numbers have a smaller range. However, the middle can have a bigger range, and that's why we need to keep in mind the border of our array, which is important. As you can see, this is repeated multiple times, and we can actually handle that later. But I think this represents it pretty clearly. But if you have a better code, please comment below and share and help us understand this problem better and explain it better. I would love to learn more from everybody. And I hope that you enjoyed this video. Like and subscribe, and I'll see you in the next one.